Ever wondered what happened when NASA's Ingenuity Mars helicopter lost communication with the Perseverance rover recently? Well, it all started on a usual Martian day, or SOL, as it's referred to by space enthusiasts and scientists alike. On May 3rd, SOL 427 of the Perseverance rover's mission at Mars, an anomaly occurred. The Ingenuity Mars helicopter, a solar-powered rotorcraft, missed a planned communication session with the Perseverance rover, marking a first in over a year of operations on the Mars surface. Ingenuity, as you may recall, became the first powered aircraft to operate on another world on April 19, 2021. It was designed to perform up to 5 experimental test flights over a span of 30 Martian days, or close to 31 Earth days, and it has far exceeded expectations, flying over 4.2 miles across 28 sorties and operating from the surface of the red planet for over a year. But back to the communication dropout. Data downlinked indicated that the cause was the helicopter entering a low-power state, potentially due to the seasonal increase in the amount of dust in the Martian atmosphere and lower temperatures as winter approaches. This dust diminished the amount of sunlight hitting the solar array, reducing Ingenuity's ability to recharge its 6 lithium-ion batteries. When the battery pack's state of charge dropped below a lower limit, the helicopter's Field Programmable Gate Array, or FPGA, was powered down. The FPGA is crucial in managing Ingenuity's operational state, switching the other avionics elements on and off as needed to maximize power conservation. It also operates the heaters that enable the helicopter to survive the frigid Martian nights, maintains precise spacecraft time, and controls when the helicopter is scheduled to wake up for communication sessions with Perseverance. However, when the FPGA lost power during the Martian night, the helicopter's onboard clock, which designates the time that communications with Perseverance occur, reset. And Ingenuity's heaters, so vital to keeping electronics and other components within operational temperatures, turned off. As the sun rose the next morning and the solar array began to charge the batteries, the helicopter's clock was no longer in sync with the clock aboard the rover. Essentially, when Ingenuity thought it was time to contact Perseverance, the rover's base station wasn't listening. To ensure that Perseverance would hear a call, mission controllers at JPL commanded the rover to spend almost all of SOL 429 or May 5th listening for the helicopter's signal. The signal came at 11:45 a.m. local Mars time. The data transmitted was limited to deliberately preserve battery charge, but the helicopter's critical health and safety data were nominal. The radio link between Ingenuity and Perseverance was stable, spacecraft temperatures were within expectation, the solar array was recharging the battery at a rate expected for the season, and the battery was healthy, containing 41% of a full charge. However, one successful radio communication session does not mean Ingenuity is out of the woods. The increased dust in the air means charging the helicopter's batteries to a level that will allow important components, like the clock and heaters, to remain energized throughout the night presents a significant challenge. So, to recap, the recent communication dropout between NASA's Ingenuity Mars helicopter and the Perseverance rover was likely caused by the seasonal increase in dust in the Martian atmosphere and lower temperatures. This led to a power loss in the helicopter, which threw off its internal clock and resulted in a missed communication session with the rover. Steps were then taken to re-establish communication and ensure the helicopter's survival through the Martian night. As we look to the future, it's clear that maintaining communication between these two remarkable machines will continue to be a challenging yet vital part of their ongoing mission on the Red Planet.
What challenges has Ingenuity, the Mars helicopter, been facing as it braves the harsh Martian environment? That's the question we're going to explore today. Over the past 3 Martian solar days, known as SOLs, Ingenuity's heaters have been working overtime. They've been kicking into gear whenever the battery temperature dips below 5 degrees Fahrenheit or minus 15 degrees Celsius. The heater's job is to prevent the temperature of critical helicopter components from dropping further, all the way down to the ambient environmental temperature of minus 112 degrees Fahrenheit or minus 80 degrees Celsius. The team, however, suspects that the battery may not be able to sustain the energy draw of the onboard heaters throughout the night. Teddy Tsanetos, Ingenuity team lead at NASA's Jet Propulsion Laboratory, has said, "We have always known that Martian winter and dust storm season would present new challenges for Ingenuity, specifically colder sols, an increase in atmospheric dust, and more frequent dust storms. Every flight and every mile of distance flown beyond the original 30-sol mission has indeed pushed the spacecraft to its limits. So what's the plan? The Ingenuity and Perseverance teams have devised a strategy they hope will make a difference. Their goal is to help the helicopter's battery accumulate enough charge during the next few sols so it can support all necessary spacecraft systems during the cold Martian night. The new commands, uplinked recently, lower the point at which the helicopter energizes its heaters. Instead of activating when the battery falls below 5 degrees Fahrenheit, the heaters now kick in at minus 40 degrees Fahrenheit. The helicopter then shuts down quickly, rather than using up the battery charge with the heaters. The team hopes this strategy will allow the battery to retain whatever charge it collected during the day. The engineers hope that after several days of the helicopter's array soaking in the limited rays, the battery will have reached a point where the spacecraft can return to normal operations. However, this strategy is not without its risks. Allowing the heaters to remain off overnight conserves significant battery energy, but it also exposes components to the cold of Martian night. Many of these components are commercial off-the-shelf parts that weren't designed for the cold of deep space operations. Despite these challenges, Tsanetos remains optimistic, stating, "Our top priority is to maintain communications with Ingenuity in the next few sols, but even then, we know that there will be significant challenges ahead." He adds, "We are hopeful that we can accumulate battery charge in order to return to nominal operations and continue our mission into the weeks ahead." To summarize, Ingenuity has been facing the challenge of sustaining battery charge in the harsh, cold Martian environment. The solution proposed by the team is a new strategy to lower the point at which the helicopter's heaters activate in hopes of conserving battery energy and allowing the helicopter to return to normal operations. However, this solution also presents a new challenge of exposing components to the cold of Martian night. The team remains hopeful and committed to overcoming these challenges, with the ultimate goal of continuing the mission into the weeks ahead.